Hello, Chemistry 10 and Chemistry 10H students. This is Mrs. Altman, and in this video, I will be reviewing how to balance chemical equations. You can see that this says that this is part 1 because in part 2, I will be covering the portion of this section that is just for the Chemistry 10H students. Before we get into some examples, we're going to review some terminology. So the first is what a subscript is. So those are the small numbers on the bottom. They show the composition of a compound or of an element. So I'll draw it out so you can understand what this means. So the 2 in CO2, that's a subscript. So what that means is I have a molecule that has 1 carbon, because if there's nothing listed there, the assumption is that it is 1, and 2 oxygen. So it looks a little something like this, or the 4 in CH4. And you don't need to worry about how I know the shapes of these. That's a whole other story that we'll get into a little bit later. So the subscripts, they tell you about the composition, what the molecule actually looks like, whereas the coefficient, they tell us how many of them there are. So if it says 4H2O, that means that I've got 4 water molecules. And you don't need to worry right now how I know that it's shaped that way. That is, again, a topic for another time. It's a bent tetrahedral shape. But the important thing is that there are 4 of them, so that was where coefficient comes from, whereas the subscripts tell you what the molecule actually looks like. So when we balance chemical equations, the reason why we have to do that is to make sure we've got the same number of each type of atom before the reaction and after the reaction. Because if we don't, that means that we are violating the law of conservation of mass, which states that atoms are neither created nor destroyed in a chemical reaction. So I've listed a step-by-step process here, but this is just to give you a starting point. There really is not a process to balancing chemical equations in the way that there is when we are converting, say, from one unit to another. This is just a general guideline that helps some students, and there are many different ways to do it. The first step, which is something that's going to be more in the part 2, is just to write the reactions and reactants and products. You'll see that all the ones we do today, that's already done for you. The second step, and I'll elaborate on this with the example, we're going to start with the most complex molecule, but the very important thing is that you can only change coefficients. Once you've changed your coefficients, you're going to check that your answer is correct. And then the fourth step, which you don't have to do super frequently, is simplify if need be. So if you have the coefficients 2, 4, 2, 4, you would divide them all by 2 to be 1, 2, 1, 2. You're not going to need to do that too much, but we're going to go ahead and add this rule here because once in a while you do have to do it. All right, let's work through these examples together. I'm going to walk you through my thought process to them, which could be different from yours, and there's more than one correct way to do it. That's totally fine. So for the first example, I could start either by looking at H2 or by looking at Cl2. It actually doesn't matter. I'm going to start by looking at the Cl2. I see that right here that I only have 1 chlorine, whereas I have 2 on my left side. So I put a 2 right here. Then I see that the H2 balances it out. One sort of trick that some students like to do is to create a table to check your answers. So it's reactants, products, and then you just list out your chemicals. So I've got 2 hydrogens in my reactants, 2 in my products, 2 chlorines in my reactants, 2 chlorines in my product. If your table checks out, you know your answer is right. Sometimes you'll have to simplify. I didn't need to here. All right, moving on to the next one. I'm going to start with Al2O3 because it is the most complex molecule. I'm going to then look at oxygen because it's the second most complex one. I see I've got 3 on my right and only 2 on my left. So I have to make them both 6. That is my lowest common multiple. The way I do that is by putting a 2 here and a 3 here. But now my aluminum is not balanced. I've got 2 times 2, 4 on my right. So I have to put a 4 here to balance it out. So then I can just make a table just to make sure that I did this correctly. So I've got 4 aluminum on my left. 2 times 2 is 4 aluminums on the right. And then for my oxygen, I've got 3 times 2 is 6 oxygens on my left, and 2 times 3 is 6 on my right. 4, 3, 2, I can't simplify that, so I am done. Moving on to my next one. I'm going to start with CH4, though it would be equally correct to start really at CO2 or H2O. My carbons look fine, but my hydrogens are not fine. So I have 4 on my left, I only have 2 on my right. So I put a 2 here. So now I've got 4 hydrogens. Now I need to balance out my oxygen. So on my right side, I've got 2 plus 2, because I've got 2 coming from the carbon dioxide, and I've got 2 times 1, 2 coming from the H2O. So I've got a total of 4. So to have 4 over here, I have to put a 2 here. So sometimes you will need to add them together. And then I check my answers. I've got 1 carbon on my left and 1 carbon on my right. I've got 4 hydrogens on my left, and 2 times 2 is 4 oxygens on my right. I've got 2 times 2 to be 4 oxygens on my left, and I've got 2 plus 2 is 4 on my right. Okay, and then one more. I'm going to start with AgNO3, just because it looks the most complex. My silvers look okay. My nitrogens look okay. My oxygens look okay. So everything's balanced. I look and I see sodium's balanced, chlorine's balanced. So for this, you could just write balanced. You're not always going to need to put coefficients in there. Right, so these ones are a little bit more complicated. This would be something I would be more likely to put just on a chemistry 10H assessment, not on a chemistry 10 assessment. But those of you in the 10 class, it would still be worth your time to try these so that you could have practiced something that's just a little bit harder than what you would have seen on your test. And I'm specifically talking about the first one here. Actually, the second one I could put on a 10H or a 10 assessment, but the first one is something I would stick to, just the 10H. Right, so I'd start this very similarly to the other ones. I start by looking at my C4H10. I'm going to start by balancing out my carbons. I put a 4 here to balance it. Then I go to balance my hydrogens, and I put a 5 here. So then I'm trying to balance my oxygens. I've got 4 times 2 oxygens for my CO2 plus 5 from my H2O. So that's 8 plus 5. So I have 13. You can't make this 13. When you end up in this position where you want to put a fraction in front of this oxygen and you end up with an impossible task, just sort of a trick that will be useful, is you can just put a 2 in front of your most complex molecule, and then it makes the whole problem so much easier. So now I have to put an 8 here to balance out my 8 carbons. I've got 20 hydrogens, so I have to put a 10 here. So now I've got 16 oxygens coming from my CO2, plus I've got 10 coming from my H2O, so 26 in total. So then I just put a 13 here to balance it out. On a test, I would typically only put 1 of this type because they do take a little bit longer than the others. And then I just check that my answers are correct. Can't simplify anything, so this is done. Now for my next one, I'm going to look at AlCl3 because it just looks like the most complicated one. My aluminums look good, but my chlorine's not, so I have to put a 3 in front here. Now my lithiums need to be balanced, so I put a 3 there. Got 3 lithiums on my left, 3 on my right, 3 chlorines on my left, 3 on my right, 1 aluminum on my left, 1 aluminum on my right. And then the last one. So when people have a polyatomic ion, these parentheses, one thing that many students like to do is to rewrite it where you distribute out the two. It's actually not how I personally do it, but I see that a lot of students really, really benefit from doing it this way. So that's why I am showing it. So I'm going to actually start with my CaO2H2. I see that my calciums are balanced. The only thing that is not balanced is I've got 2 plus 2, 4 hydrogens on my left, whereas I only have 2 on my right. So I put a 2 here. And in doing so, my entire equation is actually balanced. So I've got 2 plus 2 on my right is 4. I've got 2 times 2 on my right to be 4. For sulfur, I just have 1 on each side. For oxygen, I've got 4 plus 2 is 6 on my left. 2 plus 4 equals 6 on my right. And then I've got 1 calcium on either side. Okay, that is all for today's video. Thank you so much for watching and have a great night.